Okay, so here, as usual, I'll be doing a complete walkthrough. So without further ado, let's go right into it, yeah? This is published 25th July 2015. So if you actually want a copy of this paper, you can go on the Gov website or just type Key Stage 2 Maths 2016 sample, and you should be able to get all 3 papers. Let's move forward. As usual, you're only given 40 minutes to do this. Always do your working on the boxes. I'm going to do it everywhere on the paper because it's fine by me, but make sure your final answers always lie in the white box here. And don't waste too much time. Just, if you can do it, do it. Otherwise, leave it and come back to it later. Anyway, question 1. Let's do this together. Let's walk through it. So here is a diagram for sorting numbers. Write one number in each box. 1 is done for you. So it tells us that 30 is a multiple of 3 and a multiple of 5. Yep, so it's in the 3 times table, 5 times table. Check. Now, write a number that is in the 3 times table but not in the 5. Well, I can think of many. Just start counting from 3s. So 3, 6, 9. So we just said a lot. So I'm just going to pick 6. So pick a number that's a multiple of 5 in the 5 times table but not in the 3 times table. So we've got 5, 10. I'll just say 10. So you have a lot of answers here. So pick a number that's not in the 3s or the 5 times table. So let's say 2. 2 is no multiple of 3 and no multiple of 5. Now, next question. Here is part of a number line. Write the missing numbers in the boxes. So we're going to go from one number, we add 7 to it, gets to -5, add another 7 to a new number. So let's find out this second number first. If you have -5 and you're adding 7 more, well, the trick is to add 5 more first to get 0. And then add 2 more to get +2. If you want to go backwards, it's the same thing. You subtract -7. So going backwards, we need to subtract -7. So -5 going back 7 more will give us -12 on the number line. Number 3. Look at this number. We got 23,451.96. Write the digit that is in the hundreds place. Well, just start labeling. We know this is of course the units, the tens. The 4 is clearly in the hundreds. So we write the digit 4, the digit only, yeah? Write the digit that is in the hundredths place. So this is the hundredths after the decimal. So the 9 represents the tenths. The 6 represents the hundredths. So it'll be 6. Okay. Number 4. Oh, this one was quite fun. So a school plans to collect £200 between January and May. That's quite a bit of money. This chart shows how much they collected by the end of April. So far, it looks like they collected 20 here, a good amount of money in February, a bit in March, a nice chunk in April. So it looks like they're around just after 160 quid. And the target is here. Write the name of each month where they collected more than £50. So here, let's just say it was £20. So here, what is it? Let's say, I don't know. This seems like it's just after 70. So 70 minus 20 is 50. So this is a bit more than 50. So we can write £50 plus. So we can say firstly Feb was the first one. March, well, that's obviously small. April looks bigger than February. It starts at 100 and goes up to over 160. So this is of course more than £60. So we can say April 2. How much money did they collect in February and March altogether? So in February, just look at the values. So it starts at 20 and it goes up to 100. So they collected this much money. So between 120, they collected 100 take away 20, which is £80. So 100 take away 20, they collected 80 quid. Number 5. Chen pours 165 milliliters of milk into a measuring jug. Oh, I'm actually feeling a hot cocoa right about now, you know. Draw an arrow on the jug to show the level of the milk. So 165, so that's just a bit bigger than 160, and there's little gaps here. This is going up in 10, so this is 170. So it's actually around here. So this is where the milk is. Halfway between these numbers is 165 milliliters. So we're going to draw an arrow on the jug. So we have to say, it's kind of hard to draw an arrow over here, yeah? All of this would be the milk. Okay, easy stuff, yeah? So just make sure, let me zoom in, as long as you can distinguish the fact that it's between 160 and 170, then you're good. Okay, let's move forward. Right, question 6. So here are 6 cards. So you got the 10, the powers of 10 and of multiplication and division right here. So use a card to complete each calculation. So 5.3 something will give us 0.53. Well, firstly, the numbers become smaller and it's moved one digit. So if it's become smaller, we're going to divide. And if it's one digit, it's 10. So divide by 10. Okay. The next one, 5.3, and now it looks like it's increased and it's gone really big. It's moved actually 3 digits. So the decimals here, it's moved 3 across. So numbers with 3 zeros and it's getting bigger, we multiply and it's 1,000. So just count, use the zeros over here to count how many digits, yeah? Now, 5.3, and it looks like it's gone even smaller than the first. It looks like the first one, but moved one extra digit. So it's moved a total of, let's see, 2 digits. So from here to here. So a number that's smaller, divide, but 2 zeros, so 100. Yep, that's all. Okay, so this is even a challenge for me. So write the number 53,148 words. So just think about what you said, yeah? 53,100 100 and oops, oh, my pen faded away. 100 and what's it? 48. So 48. Easy. Oh, I have to use a ruler. So here is a shaded shape on a grid. The shape is translated so that the point A moves to point B. Okay. So translation means that it just moves across. Okay, that's all it is. Draw the shape in its new position. So basically, the point on the corner of shape A is now moved here. So you just have to copy this exact shape, except that it's moved here. So the idea is to look over here. Make sure you use a ruler, guys. I'm going to do it sketch freehand. From A, it moves 2 across diagonally. So from B, it must move 2 across diagonally. So the line is something like this, of course, straight. And then from this corner, it moves 3 across diagonally, but 1 block down. So 3 across diagonally, so 1 block down. So it ends up over here. Use a ruler, yeah? Where's my, let me get my pen again. So it's a bit tricky, you know, on a computer. There you go. And now repeat the thing. So now it's going how many blocks down? So 4 blocks down and 2 across. So 4 down, 2 across. So I think it should be around here. So let's have a go. Let me just put a marker there. So it cuts through the middle is over here. And then just connect them up, yeah? Yep, that's it, guys. So this should be your new translated shape. Use a ruler. No, don't make it funky like mine, yeah? Anyway, moving on. So the mass of a 10p coin is 6.5 grams. I did not know that. The mass of a 5p coin is half the mass of a 10p coin. Really? What is the mass of all these 6 coins together? Okay, first things first. Add up all the money, then let's find the mass, yeah? So, or you can just add up the mass right now. So this, you got 10, so you got 6.5, 6.5, 6.5, and then you got these 3, which is half of 6.5s. So combine these together, you make another 6.5 plus another, and then you just add the half of 6.5. So first thing, half of 6.5 means you divide 6.5 by 2. So how many times does 2 go into 6? Well, it goes exactly 3 times. You want to see how many times it fits. 2 goes into 5 exactly 2 times with 1 remainder. And if you got an extra remainder, no numbers, just add a 0. So now we have 10. Now 2 goes into 10 exactly 5 times. So yes, this is the weight of a 5p coin. So we can say just one 5p coin would be 3.25 grams. Now lastly, just add all these up. So 6.5 add 6.5. You can use the column method or just do it mentally. 6 and 6 is 12, so an extra half would be 13. So these two make 13. These two also make 13. Now we added the 3.25. So 13 is 26. So we should get 29.25. So I'll just do this simple math. So 13 plus 13, just make it easy for yourself here. Just draw a column. 13, 13, and 3.25. So make sure if you got points, just put zeros in, yeah? So these two will give you 25 because you're adding nothing. 3 threes make 9 and you have a 2. And that's it, guys. 29.25 grams. Voila, easy. Moving on. So it looks like we're halfway. So there's 20 questions as tests and we're on 10. Once we do 10, we'll be bang in the center. Right. So a bag of 5 lemons cost £1. So 5 lemons, £1, meaning a single lemon, if you divide it by 5, so 5 into £1, you should realize it's 20p. So this should give you exactly 20p. So 5 into 1 goes nothing, carry the 1. 5 goes to 10 2 times, and 5 goes to nothing, nothing. So 1 lemon is 20p. A bag of 4 oranges costs £1.80. So divide this by 4 to find how many per orange is. So 4 into 180. 4 goes to 1 0 times. Carry the 1, so 4 into 18. So how many times 4 goes into 18? It should be 4 times, because 4 times 4 is 16. Remainder 2. And 4 goes into 20 exactly 5 times, because 5 times 4 is 20. So that means each orange costs 45p. So 1 orange is 45 pence. Okay, now we read the question. So how much more does 1 orange cost than 1 lemon? Well, if 1 orange is 45 and 1 lemon is 20p, if you subtract them, you should get an answer of 25 pence. 1 orange is 25p more expensive. Yeah, that's all. Number 11, write the 4 missing digits to make this addition correct. So for every addition problem, always start on the right hand side. Yeah, the far right, move across. So let's have a go at this. Firstly, 8 plus something must give 9. Well, I could think of this one as 1s, because 8 plus 1 is 9. Now next one, something plus 9 is 1. Well, because you got 1 here, you got to think of a number that must have carried over like an extra 1. So something like 11, because that's the only way you can get to the 1 here. So something plus 9 gives you 11. Well, I can think of that as 2. 2 plus 9 is 11. Carry the 1. Now 1 plus 6 plus something gives you 0. So just like the previous one, to get 0, it was probably a 10, because you need to cycle to get to 10. So 1 plus 6 is 7. 7 plus something is 10. I can think of 3. 3 plus 7 is 10. And finally, 1 plus something plus 3 is 9. 1 and 3 makes 4. To make 9, you need 5 more. And that's it. This should be the final result. Number 12. 2 decimal numbers add together to equal 1. One of the numbers is 0.07. What is the other number? Well, the way I do this, just subtract it, yeah? So to make your life easy, so 1.000, take away 0.007. You go put the extra points so you can match the decimals. Now here comes the long subtraction. So nothing take away 7 is you can't do, so you need to borrow. Because you can't borrow, you have to borrow from the very first 1. Cross it 0 and carry the 1. So now you got 10. Now you need to borrow the 10, so that becomes a 9 and give to the 1 here. Now you borrow from this one, becomes 9, and this becomes a 10. Yeah, it's a lot of borrowing, guys. So 10 take away 7 is 3. 9 take away nothing is 9. 9 again, and nothing take away nothing is nothing. So the other number is 993. You could do this mentally, but just to be on the safe side, it's always good to subtract. Alright guys, number 13. So let's check out. So here are 4 fraction cards, all different fractions, but it looks like they're going up in the 4s actually. And now it tells us to use any 3 of these cards to make this entire statement correct. In other words, we need a number here which is less than this number and less than the third number. Now, when it comes to fractions, the only way to make this possible if they had common denominators. And to do that, I guess we need to raise them all to the same power, to the same fraction. The highest is 16, and thankfully these are all in the 4 times table, so we can kind of hopefully work around it. Let's make them all over 16, see if we can move from there. So the first fraction, 7 over 16, seems okay. To get this one, to get the second fraction to 16, we can just double it. So this would be instantly 10 over 16, because doubling this will keep it balanced. To get this to 16, we realize that to get 4 to 16, we can multiply it by 4. So we can multiply this entire fraction up and down by 4, and she gives us 12 over 16, because 3 times 4 is 12. Now this leaves us with 6 over 12. Sadly, we can't multiply it really to get to 16, but what we could do is actually reduce it, because we can see that 6 over 12 can be simplified to 1 over 2. Why? Because 6 is exactly half of 12. We can divide them both by 6, you get 1 and 2. Now, but we can raise 1 over 2 to over 16 because we know that 2 times 8 will give us 16. So timesing this by 8, we should get exactly 8 over 16. And yes, now we have a list of fractions we can work with. So, because we can use any three cards, let's make it easy. Let's just pick the smallest first, yeah? So the smallest fraction here, you got 12, 10, 8, and 7. 7, 16 is clearly the smallest. It looked the biggest, but it really is the smallest. So that's done. Now we've got any two more. So we can say now, the next one would be 8 over 16, which is a half, which is 6 over 12. So 6 over 12 card can go here. And that's been chosen, so we can cross these out. Now we just pick any two more. Since these are both bigger, I'm just going to go chronologically. So I'm going to pick 5/8. You can pick 3/4 of 5/8 in the end. And yeah, so my personal advice is to pick the smallest first and the biggest in the end, or one of the biggest, and you should be fine. So let's move on. All right, number 14. So here is a number pyramid. The product in a box, the number in the box is the product of the two numbers below it. Ooh, challenging. Write the numbers. So basically, we need to pick a number that will make the number above. So 2 times something is 5. So if you know your times table well, we know that 2 times 2 is 4, and 2 times 3 is 6. So the number between 2 and 3 is 2.5, or 2.5. 2.5 times 2 is 5. Okay, now this one's a bit nasty. So 5 times something gives you 22.5. Same thing in a way, yeah? So we know that 5 times 4 is 20, so I'll write down 5 times 4 is 20, and we know that 5 times 5 is 25. And if you realize carefully, 22.5 is directly in the middle of these two, so it must be in the middle of 4 and 5. Halfway between 4 and 5 is 4.5. Another way we could have done is just done 5 into 22.5, which will also give us answer, by the way. 5 into 22 goes exactly 4 times, remainder 2. 4 into 25 gives us 5. So yes, you could do that way. Now, lastly, 2 times something gives us 4.5. So this one's, I think it's best to use division just to be safe. So let's do 2 into 4.5. So 2 goes into 4 exactly 2 times. Copy the point. 2 goes into 5 exactly 2 times, and we've got 1 remainder. So because there's no more digits, add a big fat 0. Now 2 into 10 goes 5 times. And that's it. So the answer would be 2.25. All right, number 15. So join dots on the grid to make a quadrilateral that has 3 acute angles. Oh, this one's definitely, I can see this one slipping up on a lot of people's minds. So first thing says 3 acute angles. What it's telling us is that we need a shape that has 3 angles less than 90 degrees. Okay, so this is the key point here. Now, the only shape I can think of in mind, so if I was going to do a rough sketch, it will look a bit like this. You should try and consider a V shape and then bend it down like this, because then you realize you got 1, 2, 3, and voila. And then this is the only huge obtuse or reflex angle there. Yeah, so make sure you do this kind of shape. So I'll take one corner here. Let me see. Yep. Let's try it here. Let's try and make a shape in this pattern here. So try and copy this shape. Oh yeah, I don't have a ruler unfortunately, so I can't make it super neat. But try. Oh god, that is just awful. That is yeah. So make sure you have a ruler, guys. Yeah, it's kind of really hard to get it right on the PC sometimes. So this angle should be okay. Yep. Never mind. Bear with me a second, guys. You can fast forward it for 10 seconds. So yeah, use a very small angle. So you work from here, here, and here, because this is a very tight gap. So this is one angle here, one angle there, and one angle there, and that's it. So here is your acute angle. These are definitely less than 90 degrees, no matter how you see it. And there you go, done. Right, number 16. So, how do we do this one? So Lara chooses a number less than 100. So let's just pick a number n and say this one is less than 100. So this number, she divides it by 3, then subtracts 11. She then divides this answer she gets by 2, and finally she should end up with 10.5. What was the number she started with? Now, this is a very famous case of inverse operation. So every time you get an answer, you have to get the original number, you need to go backwards. So you need to do the whole process in reverse. So we need to do everything backwards. Now, let's start from the back. So it said that she divides a certain result by 2 and gets 10.5. So what you could do, instead of dividing by 2, you multiply by 2. And if you do that, 10.5 times 2 should give you a 21. Now, from this point on, so let me put 21 here actually. So doing it backwards, so it says here that subtracts 11. So the opposite of subtracting 11 is adding 11. So 21 plus 11 should give us 32. Finally, in the beginning it says divide by 3. So instead of dividing by 3, we multiply by 3. So it'll be 32 times 3. And 32 times 3 is quite easy. It would be 96. Oh my god, that was so slow. And there we go, and this answer is less than 100, and yes. So the number you started with was 96. Yeah, so just take your time, guys, and it should be fine. I'm getting a bit tired. So number 17, the model with 20 is made with 20 cubes. All right, so it's a kind of cute giraffe. What percentage of the cubes is the model is black? What percentage of the cubes in the model is black? So let's go ahead and count it. So the way it works, we count the number of blacks. We got 1, 2, 3, 4, 5, 6, 7. So 7 cubes, which are black, over all the 20 is actually black. So now we convert this as a percentage. If you know your over 20s, this would be easy. Otherwise, a quick way to realize is that 20 is just 5 times away from 100. And the easy way to convert a percentage is to make a fraction over 100. To do that, we multiply by 5 to get to 100, and we do the same to the top. So 7 times 5 is 35, and 35 over 100 is identical to 35%. And voila, the answer is 35% are black, meaning 65% must be white. Next one. So 18. So here are the ingredients for chocolate ice cream. So you're given a lot of information here. Now Stefan has only 300 milliliters of cream to make chocolate ice cream. How much chocolate should he use? Right. So cream, you need 400 milliliters. So you can see that he actually has 3/4 worth of this. So that means for chocolate, he needs 3/4 of 120. So 3/4 of 120. So off we can put a time sign, and then we just do the maths. Now the easy way to solve this is that you can divide first. So you ask yourself, how many 4s go to 120? Well, how many 4s go to 12? We know it's 3. And in this case, 120 be 30. So the answer would be 30, and then we multiply that by 3, so it'd be 3 times 30, which is finally 90 grams. Easy stuff, guys. Here we go, number 19. So the area of a rugby pitch is 6,108 square meters. A football pitch measures 112 meters long and 82 meters wide. How much larger is the area of the football pitch than the area of the rugby pitch? Very easy. So this is just a case of, you can imagine the football pitch is a rectangle, and you just multiply these to get the area. So let's do it now. And once we find the area, we can just subtract it to find the actual difference. So what do we have? So 112 times 82. Not so bad. Not so bad to work out. So to work this out, I like doing 2 parts. I prefer it this way. I like to say what's 112 times 2 first, and then 112 times 80, just to avoid making mistakes. And then I plug the answer here. So 112 times 2, so double it instantaneously, you can just say it's 224, or just work it out individually. For 112 times 80, well, first do 112 times 8, so 8 times 2 is 16, carry the 1. 1 times 8 is 8, plus 1 is 9, and 8 times 1 is 8. And because it's a tens, you stick a 0. Very important. Lastly, put these numbers back in, just add them up. So it'd be 8, 9, 60 plus 224. Adding these up, you should get 4, 8, 11, carry the 1, and 1 plus 8 is 9. So now we can see that the football pitch is so much bigger than the actual rugby pitch. The question is, how much times bigger is it? So just to double check, the The way to do this, we just have to subtract the numbers. So we can say therefore, I'm going to change the color pen, is bigger by, so what, 9184 minus 6108. Okay, let's have a go. So firstly, 4 take away 8, we can't do, so we need to borrow off his neighbor, the 8. That becomes a 7, carry the 1. 14 take away 8 should give us a 6. 7 take away 0 is 7, and 1 take away 1 is nothing, and finally 9 take away 6 is 3. So it's bigger by 3076 square meters. So much bigger, really. Whew. Almost done, guys, almost done. Finally, so question 20. So here are 2 identical shaded triangles on corner axes. So you're given 2 triangles labeled from the origin to 03 and 38, and likewise here. Write down the corners of A and B. Oh God, so easy, man. I'm so happy. Is this the final question? Oh yes. So the way this works, this is just a translation. So the easiest way to do it is to just pick the corner that's already done, like 9, 0 and 8, 0 and 0, 8. See how long it's moved. So we can see that it moved from 0 to 9 by 9 places across. So 9 this way. And it's moved down from 8 to O. So from 8 to 0. So it went down the y-axis by 8. So what does this tell us? This means that this corner here, 3, has moved 9 across. So it should be 12. So A should be 12 firstly. And it's moved down by 8. So it should be 0. So the first pair is 12, 0. As for B, we look at this corner. So at this point, this is the origin. So this is automatically assigned 0, 0. And following the rules, it's moved 9 across. So it's over here. So it's at 9, 0. And then moves 8 down. So it'll be 9 and minus 8. And that's it, guys. That's literally how you determine the corners here. By translation, you just take your time and hopefully get the right result. And yeah, looks like we're done for today, man. And if you kept up all the way here, I just want to say congratulations, well done, and hopefully you guys smash it on the day of your SATs. But other than that, I shall see you all in the next video. Ciao.